if ever I suspect that somebody's processing my data without my consent, all I have to do is say, okay, cool, show me the record of when you queried the live hash to verify that that document was still valid. And if they can't, then they've just violated consent. So it becomes something that's enforceable on the back end. And so that's the cool thing about the idea of having these hashes or live hashes in Hedera is that they're revocable. And because you're getting a record from a distributed ledger, I can ask you to prove that my consent was still active when you used my data.
Welcome to Hedera Hashgraphs, gossip about gossip. If you are a developer, an entrepreneur, crypto enthusiast, or just trying to learn more about how distributed ledger technology and Hedera Hashgraph will impact your industry, then you'll love the episodes that we have coming up. Bookmark us, add us to your podcast app, and stay tuned.
Hey there, I'm Paul Madsen. Welcome to Hedera Hashgraph, gossip about gossip. It's time for another tech chat with my friend and colleague, Ken Anderson. Hey, Ken.
Hey, Paul. Always exciting to be on these calls and having these discussions. Every time we have one of these discussions, there's some activity in Discord, and I get an opportunity to really explore some of these concepts and maybe even just gather my thoughts about a lot of the engagements we've had over the last few weeks.
Today's topic, dear to my heart, given where I came from, we're going to talk about identity and the value proposition of using a ledger to support identity applications or operations. I don't know if you know this, but I used to design T-shirts for a major identity conference, so I'm kind of a big deal in that world.
Kind of a big deal. Well, that's awesome. Well, I think in this scenario, you might be more of the expert than me. I'm always happy to just kind of share some of the discussions we've had, some of the workshops we've done, and maybe some of the patterns that have emerged from some of those discussions. But I think in this case, I'm equally as excited to hear some of the input you have, just given your history and expertise.
Yeah, let's get into that. Maybe I'll start the stage by summarizing what I would see as sort of the base identity transaction, if you will. And then we can talk about where a ledger like Hedera might support that. I would contend the basic identity functionality or operation or transaction is you give me something that says something about my identity, my attributes, whether it's my age, my nationality, or just your opinion of me. And then I'm able to present that credential, certificate, assertion, or it's been called so many things, elsewhere. And because of that party's trust in you, to whom I present that identity package, they're willing to give me some level of service or access that they wouldn't otherwise do. So you say something about me, other people trust what you say about me, and that is to my benefit. And so the question is, how does a ledger facilitate all the underlying pieces of that, the requirements of trust and validation of cryptography and just temporal truth? That's, I think, the proposition, right? That ledgers could somehow help with that fundamental operation. Would you agree?
Yeah, well, and I think let's take a quick step back because I think baselining our vocabulary might be helpful right now because there's lots of parties involved in the identity space. And what you just defined as me giving you some assertion. So what you're saying is that I would be the issuer or the authority in an identity relationship. You would be the subject or the holder of the attribute.
Yep.
And then there's some verifier. There's some third party that has to verify that this identity attribute was asserted by the authority. The attribute is about the subject.
Correct.
You've got the issuer, the subject, and the verifier. And then the thing that we're talking about is this identity attribute, something about you that describes you or is related to you that I, as an authority, am going to attest to, and that any third-party verifier can verify. And so a lot of this can be done with cryptography. If the verifier knows my public key as the authority or as the issuer, then you, as the subject, should be able to hand some attributes that have been signed by me as the issuer to them, and they can verify that because they already know that public key. Now the question is, do they know that public key? And if they don't, how do they discover it? And that, maybe we publish that on a website. You could publish that in a newspaper or a magazine. Maybe it's on a decentralized ledger as like a registry of sorts where people can discover those types of things. So there are multiple ways you can discover that, but really what's the value of the ledger in this? And I think there's a few pieces of value, and you might add a few more, but I think one that's really critical, especially in the Hedera case, is this concept of revocability. And I think that's really important for an authority to feel confident issuing certain identity attributes, especially with things like the right to drive. If we're just using cryptography and I sign basically a token saying that you have the right to drive until this expiration date, then how do I know that it's been revoked? How do I know that you didn't get in trouble with the law and had that right to drive, which, that is an identity attribute. Any right that we can define is an identity attribute. This is something that defines you and maybe your rights. So in that scenario, I, as we'll say the Department of Motor Vehicle in California, want to have the ability to revoke that before the expiration date on that identity attribute or that document. And that's where Hedera becomes valuable, because you have this decentralized public registry of all of these identity attributes that either the subject or the issuer can revoke the document that represents that attribute. So it gives them that ability to do that for whatever reason. Maybe we talked about this when we were talking about live hashes a few discussions ago, but maybe I want to reduce my carbon footprint. And as part of doing that, I've committed to not drive. And in so doing, I have revoked my own right to drive, or the identity attribute for my own right to drive. It might sound a little silly, but if you really believe in it, then maybe you could revoke your own identity attributes that give you certain rights. So my point being is that it becomes a revocation service that's decentralized and a registry that's decentralized. You get both a discovery component and a revocability component.
So I definitely agree that revocation is key. But you only really need revocation if your credentials or claims or whatever we're going to call them are long-lived. I've lived through manifestations of identity architectures where those claims were short-lived, lasting seconds or perhaps minutes, as long as it took to redirect through a browser. And in that world, you don't need revocation because the credentials are issued in real time. However, the implication of that model is that the issuer, as you labeled them, knows where this subject is going on the web. They know the applications at which the subject's trying to access, and that has privacy implications. So there's value from a privacy point of view in disintermediating the issuer, not from the role of being an authority about attributes, but disintermediating them from the role of real-time involvement in the issuance of credentials. They do so a priori. Those credentials live a long time. The subject holds them and controls them and presents them as they wish without the issuer's direct involvement at that time. But if you do it that way, then you need revocation. That's when something like Hedera becomes important.
Yeah. So, there are different models you can approach that particular problem with. The first model is kind of the centralized point-to-point relationship. In other words, I'm going to access your service. So you've created a profile for me and you have the authority to issue me credentials to your service. In that case, maybe using something like a JSON Web Token or some type of short-lived session token or cookie or something to that effect would be sufficient for you to reevaluate our relationship every time I try to access that service and determine whether or not you want to continue to give me access to that, because you control both the service and the authorizing privilege or the access authorization mechanism. So in that scenario, you've got kind of like this point-to-point. It's very centralized, but I would say it's pretty scalable. From an infrastructure perspective, it's probably the leanest and most brute force approach to identity. The only problem is that the end user now has to manage lots of identities because they have to have profiles and access rights for multiple services that they're going to access throughout the world. The other one is it's also centralized, but it's that federated approach. It's what we get with Facebook login and Google login and all of these different patterns of OAuth and SAML and things of that sort, the OpenID Connect approach. That's a federated approach, which is still centralized in the sense that somebody's holding on to my identity information, is playing intermediary, and is also fairly scalable. But it also means that I, as an end user, get the convenience of only having to manage a handful of credentials and getting access to lots of services. And that might be okay for the most part if it's a convenience discussion. But what you brought up, which is a privacy component and also a self-sovereign component, is this idea that why should I depend on third parties to hold any of my information for me to engage with other particular parties? And you can do that through tokens, where I just go and ask the authority for certificates every time I want to access a service. So those can be done short-lived and fairly efficiently and quickly. Or you can do it through long-lived tokens, in which case revocability becomes important. Because with a long-lived token, the idea is that I have access until it's revoked. And I don't have to refresh that token frequently. And there are also some other security implications there that you might want to consider. But I think with cryptography, we can sufficiently secure a lot of those things. But the point being is that it's kind of changing the model from these short-lived tokens that are issued by either intermediaries or the centralized services, who just say they want to give you a token for as long as they feel comfortable giving you access to the service. And then you have to refresh those tokens, which is that short-lived approach. Lots of systems and lots of tools already implement that. So it's very mature, well-established, scalable, and it's pretty straightforward. The other approach, like I said, is long-lived tokens, where you get access until you get it revoked, in which case the service only has to, or the authority, the issuer, only has to act if there's a revocation necessary. And that can be on timers on their end if they want to have expiration time. Say you've only got access for 30 days, if we're talking about things like subscriptions. Or, maybe there are other types of triggers, policy violations or contract terms that are met, or whatever those events are that trigger a revocation, in which case the authority only has to touch the authentication token of a particular user when there's a revocation. So it's less frequent than having to reissue that every time you want to access a service. So I think there's an efficiency gain in how much work you have to do. But then there's the whole idea of every time you need to revoke or check if something is revoked, there's a query round trip anyway.
Yeah, I agree there could be efficiencies because the issuer need only be involved at the initial issuance and then maybe never again if they never revoke.
That's right, yeah.
But for some issuers, they don't want to be so removed from the use of their credentials, like an enterprise, right? They want to know where their employees are going and using their credentials. So there's a trade-off, and this self-sovereign model might not work everywhere because of that separation it imposes. So you talked about, or you mentioned live hashes, and we've talked about them before. As I see it, live hashes are a way to attach, quote unquote, or bind an identity to a Hedera account. And as such, it's a way to logically inject identity into applications or transactions that rely on those crypto accounts, right? Moving HBARs or moving maybe smart contract tokens. But there is a whole wider range of identity applications that have nothing to do with HBARs, right? Just using identity out on the web. And there's a model emerging for standardizing distributed identity, like we've talked about today, that's emerging in the W3C, the so-called decentralized identity architecture. Do you want to talk about that?
Yeah, so live hashes, I know in the Hedera API in Hapi, there's actually an item called live hash, which is yet to be implemented, that is attached to accounts. But I also like to think of the file system as kind of a maybe more private and more ad hoc live hash mechanism. Because what a live hash is basically a hash of some data with some signatures, usually by the subject and the issuer, who both have revocation privileges of that hash. So to give an example, we'll talk about the right to drive. So I've got a document on my device that says the owner of this public key is allowed to drive. That's what this document says. It's a digital document. I'm going to hash that. I'm going to sign the transaction that's going to write that document or that hash to the file system. And then I'm going to collect the signature of the DMV. So I'm going to send this transaction to the DMV and say, can you countersign and submit to Hedera? And then give me the file ID back. So what happens basically is I get this file ID that is, all it is this hash. And that hash is signed by me, the subject. So I've got a public key and some authority. So the issuer, which is the DMV. And both of us have signed the transaction that now creates that file in Hedera. Now, either one of us can revoke that. That to me is a live hash. As long as that hash exists, then the underlying document is alive. As soon as that file ceased to exist, either through revocation or expiration, then the underlying document is dead. It's no longer alive and it's not trustworthy. So in that scenario, I could create a public key every time I want to create a new identity attribute. Anytime I want to create a live hash, I create a new public key. So in essence, everybody in the world is going to know what the DMV's public key is because we need to, because they're an authority, they're an issuer. But nobody's going to know which public keys belong to me or which identity attributes belong to me because I create a new public key every time I want to create a new identity attribute. Now, unless, of course, I've already given it to somebody, but they can't correlate online. They can't correlate on Hedera which public keys belong to me. They only know which public keys are associated with which files that I provided to them and proved that I owned. But they can't correlate across any other identity attributes. So maybe I go to the DMV and say, give me 10 files with my identity attribute of the right to drive. And then I'm just going to rotate which file IDs I hand to different verifiers because I don't want anybody to even be able to correlate between each other who I am. So you can add certain levels of indirection that create a certain amount of privacy. So when I say live hash, I'm also talking about the file system as well as what's related to a cryptocurrency account. In a cryptocurrency account, I think there's huge value in maybe the KYC AML space with regard to live hashes, because live hashes are identical to what I just described on the file system. You can have multiple parties sign the live hash associated with an account, and any of those parties can revoke it. And so you get the same functionality, but it's attached to an account or an account ID, in which case there is kind of that correlation component. If I've engaged with you, if you've transferred HBARs to me and you have live hashes, I can now kind of determine who you are and maybe depending on who you've gotten live hashes from, what rights you might have active. If you've got a hash from the DMV, it's very likely you've got the right to drive. And so from a privacy perspective, that may not be the most ideal configuration, but from an AML KYC component perspective, I think that's very useful and efficient. And there might be other ways to mitigate some of those privacy concerns. But if you look at the file system, you can do the same thing even now. You can do the same thing that you can with live hashes associated with crypto accounts in the file system in maybe a more private kind of self-sovereign way.
To those privacy advantages, you talked about multiple hashes. Is there a correlation risk in who pays for the maintenance of those files? If someone was determined enough, they could track the funding for those different files and presumably work it back to the same account.
Yeah, that's absolutely right. And this is where it's a question of who actually pays for those files. So does the DMV pay for those files? Does the issuer pay for those files and somehow get compensated by the subjects? That might be a useful business model to create some level of privacy, because you're going to have lots of people, lots of accounts paying the DMV for something, and then the DMV could pay for the credentials for, say, 3 years or 5 years or 10 years and store those in the file system. That might be a more private way to approach it, is that the issuer, who's the known entity, is the one paying for those files. But then we have to also take into consideration the fact that, they're not going to want to do that unless they've gotten compensated for it ahead of time, and probably with a premium. The alternative is what you're talking about. If I'm basically thinking of this as a favor from the issuer, and the issuer is already kind of going out of their way to sign this, why would I go ask them to also pay for this? So I'd probably want to pay for it myself if it's that scenario. But in that case, I'm also kind of attaching an account with a file. Potentially, if people can track that payment, which, with mirror nodes, that's going to become a trivial thing. But if you wanted to make those correlations, you definitely could. So I guess in that answer to your question is that, yeah, there's multiple ways to do that. If the subject is paying for it, then it's clear who the subject is from an account ID perspective. If the issuer is paying for it, then it may not be as clear who the subject is.
Yeah, makes sense. So in emerging architecture being normalized at the W3C, what gets stored on the ledger, whether it's a blockchain or more generally DLT, is in the simplest model, what is known as a distributed identifier document, or a DID document, little snippet of JSON that carries within it metadata about some identity. So the proposition is that the subject has a credential, they present it as they wish, they hold it, they present it. But then the relying party at which the subject party presents that credential is able to dereference an identifier within it, find this JSON on the appropriate DLT, and maybe download some public keys of the issuer. You hinted at that before. Maybe find other related endpoints to further interact with the subject. Maybe, a calendar API for the user's calendar and info. So in that model, what gets stored on Ledger is not a hash, but a small piece of JSON.
Yeah, it can be either way. If you look at the DID method specifications, Bitcoin does a hash of sorts. There are different method specifications that will do a hash. Other ones will do the full JSON LD object. Now, JSON LD is a standardized JSON format. And so a DID really is two major components. One is the resource identifier, the URI, which is kind of the string that identifies the document. That's like the title or the name of the document. So it'd be like DID : and then whatever the namespace is. If it's Hashgraph, maybe it's HHG or something like that, : and then the reference to the document itself. So some string that represents a reference to the document. And in our case, it might actually just be the file ID on Hedera. So it could be as simple as DID : HHG : file ID. I'm not saying that's what it is. I just put out a Hedera improvement proposal for that. But it could be something as simple as that. That becomes your DID or your DID, which is a document, as you said. It's a JSON document that contains a lot of information in it that would be public keys. It would be the URI itself, so the identifier itself, maybe expiration and issue dates, callback URLs. So if you want somebody to have access to your calendar, maybe you include your calendar link there, or maybe anytime somebody wants to access your service, they send a request to a particular REST API endpoint that's defined in the URL space. So lots of cool things you can do with a DID. It's a very cool standard that is becoming standard in the web space. It's something that is gaining lots of momentum, so why not gravitate towards that? So in Hedera, we can either store the full DID document, or we can store a hash of that document. So the same way we were talking about before, where it can be a hash in a self-sovereign way, I would communicate the actual document to you through private channels. And then you would just verify ownership of that document with my public key that was used to sign the hash on Hedera with the public key that's listed in the actual document, the JSON LD, the DID doc. So there's a couple ways you can do it. You can do it with hashes, or you can do the full document. It's just a matter of discovery and what information is in those documents and what you want people to see. But it's starting to become a very mature, very well supported standard that could easily live in the live hash space on Hedera.
Yeah. To your point, whether it's a hash or the actual JSON, the economics might move you in one direction or the other. You're going to be paying for the persistence of those files in the file service. So lastly, I know that you've talked to enterprises about a third scenario for using a DLT like Hedera to track identity data, that being consent, users' consent over certain operations.
So we talked a lot about live hashes. That was kind of the first thing we talked about. Then we kind of talked how DIDs fit into the live hash space and potentially just straight into the file system. Maybe we don't treat it as a live hash. It's really just a file in the file system. Okay, then there's this next component of who has the authority to act on the data that I've provided them. So whether I've provided it out of band and Hedera is used from a verification perspective to know that the data is live, the next question is, how are you allowed to use it, and how long can you use it, and how do we prove that? So there's this concept of consent. So if you are a retailer, for example, or a technology company, and you're gathering information about me and you associate it with my identity. So this is personal identifying information, or maybe even just usage data of their technology. And the question is, how can they use that? Especially the PII side. We really need to be sensitive to that because of regulations. But how are they allowed to use it? Well, right now, they've got these gigantic documents that I'm sure very few people actually read that define the terms of how they're allowed to use your information. And with regulation, that's gotten a little bit more explicit and it's supposed to be more user-friendly. But they take that information, their online retailer will take that information and share it with advertisers or advertising services. And those advertising services will use our data either for serving advertisements to us or profiling us for ad servicing or whatever the case may be. But our data is being used. And this is a pretty hot topic right now, just in general, outside of the DLT space. But then the question is, okay, how do I get control over that? How do we enforce, or how do we recognize my consent and when I stop consenting? So some services, especially centralized profiling services, will say, hey, well, you can log into our service and you can look at all of your profile data and you can see how we're using it and you can download how we've used it and you can revoke how we can use certain things. And that's pretty cool. I think that's a great step in the right direction. But when I have so many services I'm using and subscribing to online, I don't want to log into every one of them and manage all of my identity attributes multiple times over across multiple services. Maybe what's easier to do is to say, okay, I'll tell you what, why don't we create this consent document that has all of the parameters, maybe very similar to what OAuth does, right? It defines what about me you're allowed to use and for what purposes and for how long. And then we just create that consent document and hash that and create a live hash from it. Now what I get to see is, I know which documents are live. So maybe I cache the original agreement document, like an OAuth doc, but I can always know what's live based off of the live hashes. Next, I can revoke those. So anytime I know that there are certain documents that I've agreed to in the past, I can just go to a central place and revoke any of those documents or all of those documents. And then lastly, and this is the part where it gets a little bit difficult because it includes regulators and the companies that use our data. If I say that a marketing agency or a profiling service is allowed to use my data, before they use my data as part of an algorithm or a processing mechanism, they should always check to make sure that the live hash is still alive, that it hasn't been revoked. And as long as they can show a record of that check before they processed my data, then we're all good. If ever I suspect that somebody's processing my data without my consent, all I have to do is say, okay, cool, show me the record of when you queried the live hash to verify that that document was still valid. And if they can't, then they've just violated consent. So it becomes something that's enforceable on the back end. And so that's the cool thing about the idea of having these hashes or live hashes in Hedera, is that they're revocable. And because you're getting a record from a distributed ledger, I can ask you to prove that my consent was still active when you used my data.
Very cool. It's a different authorization model than the live hashes we have, right? Whether attached to accounts or files where both parties can revoke. In this model, it would be the user that would have the ability to revoke their consent, not the online website at which that file was created.
Well, I think it could go both ways. I think it'd be cool if the website were proactive and said, listen, we're done using your data. You've given us consent for a period of time. We don't even want the liability of having that consent. We're going to revoke that live hash. And then I, as an end user, when I query periodically to see which live hashes are still valid based, my wallet's going to manage those agreements and live hashes. When I periodically query that, I can see and go, oh, well, this online retailer has revoked the consent I gave, which means that they've basically said they are no longer using my data. So it becomes a feedback loop for users to know that data is no longer being used.
Yeah, I see that.
That's a cool model, but to your point, it could be very unilateral if you wanted it to be, or it could be, very bilateral if you wanted it to be. So it works, I think, in both directions, and it just depends on, what liability or how online services want to use that. I think in most cases, especially when you're talking about advertising, they're going to want to have the consent as long as they are allowed to.
Yeah, true.
But in certain scenarios, where you've got a responsible retailer who wants to be proactive about their compliance with regulatory policies and ensuring that customers have a confidence in their privacy and data usage, then yeah, why wouldn't you allow a retailer to also revoke that consent?
Awesome. Thanks again, Kent.
Thank you, Paul. Talk soon.
Bye-bye.
Bye.
Thank you for listening to Hedera Hashgraph's Gossip About Gossip. If you liked the episode, please subscribe, rate and review, and also share and tell your friends.
Or connect with us on social media like Twitter, Instagram, etc. at Hashgraph, particularly if you want to leave us feedback on the podcast. We look forward to hearing from you.